What's up, guys? Welcome back to Vanover Customs and welcome back to the Lathe project. In today's video and the next couple videos, we're going to be focusing on the chip tray, the coolant pan, and the coolant pump and coolant feed setup. So we're going to start out with the chip tray. This lathe does not have a backsplash currently. It doesn't have coolant tanks, and it really doesn't have a coolant pump or any sort of feed line near the cutting tool. So we're going to be addressing all of those things. Let me bring you in a little bit closer and we're going to start out with the chip tray. As you can kind of see where I'm standing over here, there is no backsplash on this lathe. Now you don't need a backsplash. I have two lathes other than this, and my American doesn't have a backsplash, which can be nice because I can come with a camera from over here and get nice shots. But aside from that, having a backsplash really is nice, especially because it can help direct coolant and chips down into the chip tray. Now on that machine, I don't run coolant, so it's less of a big deal. But because we're taking this machine as far as we can, I really would like to have a backsplash. So this machine probably didn't come from the factory with one. However, the newer Lion machines of this size do have that backsplash, so that's what we're going to be making. Let me bring you around to the front and kind of show you how that's going to integrate with the coolant setup. We're going to get more detail oriented on these tanks when we go to fabricate them, but I just wanted to give you a general shot of what it has or lack of having and what the game plan is. So right now we have two trays that are designed to pull out the front by removing this kind of temporary shield, and these trays have basically two drains in the center that are really, really small. And I think originally this probably had two pipes running from those drains over to the coolant pump, which lived in the casting of the machine. Now that probably worked, but none of that is on the machine. Most likely it got clogged and it was removed by one of the previous owners. So what we're going to be doing is manufacturing two tanks that are square and large, so that way we can have an increased coolant capacity, and those tanks will not only integrate with these removable trays, but also our rear backsplash. So that way all of our stuff can make sure it flows onto these trays and onto the actual tanks. So that's kind of a general idea what we're going to be doing here. The next step is going to be getting the back prepared for that backsplash. One last thing before we jump into making this guy is how we're going to mount this. So I'm going to be making this out of a sheet of 9 by 4.5 16 gauge material, and I went ahead and had my metal supplier bend it at a 40-degree angle. So it's going to be 2.5 feet this way and then come in 2 feet that way. And what that's going to do is give me good spacing in this direction for clearance for the chuck, for the carriage, for everything there. And then the dive in is going to help me be able to get all the coolant and debris into these pre-existing trays, and whatever doesn't go into there will come into the back of the coolant tanks, and we'll kind of talk more about that when we get there. So the first thing I need to do is to go ahead and take that pre-bent piece, and I'm going to bring it over here with the crane and just kind of mock it up. And once we get it mocked up, then we'll figure out where we're going to create mounting points. Typically they're mounted somewhere over by the headstock and on the back of the lathe on the casting, but we're also going to have a middle support here. I'm trying to keep this somewhat light so it can be removable, but we also want it to be nice and rigid so that way it doesn't deflect when chips are hitting it. So let me bring that piece over here and we'll get it mocked up. Well, a couple people have been asking about my fixture table and how I like it, and well, you can see we're putting it to good work. We got this skeleton for the backsplash all set up, and we're using our fireball squares and the clamps that I modified to fit with this table, and overall this table works out really nicely. I do want to get that backsplash mocked up correctly, and right now it's hanging from the center, which is causing a little bit of a bend. So I figured we'd work on the skeleton first, so that way we can have some structure to that backsplash, so that way when we mock it up, it doesn't have a bow in it. So I'm gonna quickly get all this welded out. This doesn't really need to be this accurate, but I figured since we have it, we might as well use it, and then I'll bring it back once it's fully welded out. We got this skeleton all tacked and welded out, and if you guys think this is overkill, you'd be right. The main thing that we're fighting here is because this is a piece of sheet metal. I want to make sure it's rigid, so that way when we place it in place, it doesn't flex, at least flex a lot when I put on the end caps, and when I'm hanging it from the middle, it kind of was warping a little bit. So we wanted to add as much structure as possible without adding as much weight as we could. So we're using this 1/2x1. It's pretty lightweight stuff, but on end here it does add a decent amount of structure. So we got the skeleton on both sides done, and then we went ahead and welded this strip in the middle, and that's gonna kind of keep it or resist it from tacoing out. So next we're gonna get this back over to the lathe and kind of positioned so we can start working on the end caps on either end. I'm gonna work on creating this mounting area over here next. So what we're gonna do is drill some holes down here where it's flat, and then we'll drill some corresponding holes in a piece of scrap sheet metal and bring that piece past this. And then once we get this positioned, we can trace on that piece where we want it to go and then cut it out, and then we'll be able to weld in that corner. Here's a pro tip. When we're fabricating a part and we want to transfer the holes, I use some of these hole transfers. So the way these work is this container holds like 6 of them, and the end is a driver. And on the end it's threaded, and the tip is pointed. And so what that does is you take this and you put it in the driver and you put it in the hole, and you can adjust the stick out. And then, like in this case, I put a bolt in here, we put our plate on here, and then because I have a center point, I can tap it with a hammer, and that allows me to transfer the hole accurately. I use these guys all the time. I had no idea these existed until I saw someone using them. And then once I got a set, I use them all the time. I got them in sizes all the way up to 5/8, and they're really nice, especially when you're doing multiple holes. And it's fabrication, you know, nothing crazy you're going to do on the milling machine, but you just need it to line up. They're plenty accurate enough for a clearance lineup, especially when you have a hole to pivot off of, and you can use it in multiple shots. So I really like these guys. We got this piece bolted up and welded to this, and it's looking real nice. I left it a little bit tall because I want to transition from that height over here. So we'll probably come down at an angle and then come over so we can finish that out. Now that this side is constrained, I was able to jack up that side, make sure the height is good as far as like level, and then I cut a board that I can place over here to kind of measure the distance, and then go over there and do the same thing so I can tweak this forward and aft. So that way alignment is good in and out and up and down. So we're looking really good there. The next step is to come over to this other side around the back and make a mount kind of similar what we did over here, both with the sheet metal and with drilling into the side of the casting to make a bracket. So let me bring you around to that side and show you what we need to do to start with the bracket first. Over at the back side of the lathe, you can see what we're working with next. Let me answer a question that's kind of the elephant in the room, and that is, why did we make this short and not the full length of the lathe? If you look at the newer line lathe, the chip tray or pan or backsplash comes all the way to the back, and they have a nice piece of sheet metal coming out and connecting to that. Now that would be nice, but there's a couple reasons we didn't do it. First and foremost, on this style lathe, there's actually a motor in here, and so there's currently a plate here, so it'd make kind of continuing a piece of sheet metal a little bit more complex because we need to integrate it with that, whereas on the newer one, the motor is in the carriage, and this is pretty much blank. The other thing is, on this lathe, the chip trays end about a foot forward of the end, so bringing this past farther wouldn't really give us much advantage because basically it would just kind of fall onto the floor where there's a gap here. And lastly, my shop is really tight on space. I don't know if you notice here, but this is pretty close to this. This is pretty close to this, and there's not a whole lot of room. And this lathe is actually going to be coming back another 1.5 to 2 feet, and that's where it will live. So not bringing this back all the way will not only allow me to kind of work this lathe into this cavity, but it will also give me access to the coolant pump, which is going to live right here. We haven't got into the design details yet, but I'm going to have 2 separate coolant tanks with a 3rd remote reservoir for the pump, and it's going to live right here. And this space, you know, between here and here will just allow me some nice access to kind of weasel my way in between the crane and here and access the pump a little bit easier. So, but even though we're doing it that way, we're not going to have the ease of mounting that we would be on the end. So we need to come in here and basically bolt a block of steel to the casting so we can come over and attach to that. So the next step, I'm going to come in here and just scale this, get rid of all the paint that's chipped, and then we'll drill and tap some holes and we'll just mount a block. And then once that block is mounted, we can fabricate our sheet metal mount and have it just screw into that block. So let's go ahead and start on preparing for that block. We got a nice hunk of steel over here, gonna be overkill, but hey, that's what we're going with. It'll make a nice face to mount some bolts to. We're just gonna drill 2 5/8 holes over at the radial arm drill. No pre-drilling, just knocking these bad boys out. Grab some coolant. Let me up my feed, I'm at 6. Let me throw it to 11. That's why I like this, it's efficient. We're just eyeballing this, doesn't matter at all. Got a little aggressive there on the feed. Looks like part moved on us. Well, that concludes the fabrication of the Backsplash, and guys, it turned out really nice. I think when this is painted and installed, it is going to look just as good as factory and obviously have the benefits of being custom made. So what's next? So the first thing is first, what are we going to be painting this with? So a little bit unusual, but like my other lathe, I painted that Backsplash with a bed liner material, and that bed liner has held up really well in the last 3 to 4 years. I like it because it does a couple of things. One, it's really durable, so with all the chips flying at this, the paint doesn't tend to chip. And a lot of lathes, if you look in this region over by the chuck, you have a big paintless area, and it's not a big deal, it's cosmetic, but I think doing that gives a nice coating and nice durability, so that's the first thing. And the other thing is it provides a little bit of sound deadening. This stuff can be kind of echoey because it's sheet metal, and on certain parts on the lathe, specifically when you're turning something that has a lot of vibration, sometimes you can get like a ringing from your Backsplash or the chip pan because it's sheet metal. So kind of dampening some of that sound with a rubberized type coating is beneficial in that regard. And also the black, I think, looks good and looks good dirty. Most of these are painted the same color as the lathe. So instead of doing a roll-on bed liner, we're going to go full send like the rest of the project, and I'm actually going to get this Linex, which is the best bed liner they make. I've already talked to the guys. They're going to strip down the hot roll finish and Linex it with about 80 to 120 thousandths thickness. So that should be plenty durable and add a really nice sound deadening to it, and it should be very, very durable and last a long time. So that will not only look really, really nice, but it will go ahead and make sure everything is sealed and protect it from future abrasion. A couple of notes on the fabrication of this bad boy. So our diverter shield over here that you see me working in one of the last clips worked out really nice. I flow tested it just to make sure the angle was steep enough to divert water, and it is. And then we went ahead and did a lip all the way over to the end, so any water that hits there will run over. And then I water tested that just to make sure that it was gonna flow into the existing chip pans, and it does. I went ahead and ground all the spot welds on the front side. I think the texture from the coating would cover it, but I just wanted to be safe. And then on the back, now that we have it kind of on the crane here, I went ahead and added a counterweight over here. So as you can see, it's hanging nice and level. Not necessary, but I did that just for install. This thing's kind of a bear. So we do have a weld nut up here so I can take out the hook, and it just kind of helps me install it easier because before it was kind of at an angle. So that's nice. We have some brackets that I just welded on off camera that goes to that middle support. Is it necessary? Not really with how rigid it is, but it gives a little bit more support in the middle since this is a long run, and you can kind of get a more full picture of all the structure on the back. And then here's kind of a really nice profile of this side here as well. So yeah, turned out really, really nice. Now for the back, we are not going to be bed lining it. It would be useless. We're just gonna come in here and paint it either the lathe color or maybe like a gray. It doesn't matter. We're just gonna protect it from rusting. So yeah, that's pretty much everything with the Backsplash. The next step is going to be making the coolant tanks. A little bit of insight into that next video. We're gonna be making 3 solid stainless steel tanks. Almost 80 to 100 gallon capacity. Is that necessary? No. Have I ever seen a stainless steel lathe coolant pan? No, but I think it'll make for a great video. It'll make a tank that'll last forever, and it will look killer. So stick around for that video. If you guys have any questions about this build, let me know down below in the comments, and we will see you in the next one.